Today we're on page 4 of the AP Chemistry Chapter 15 packet, and we're going to be discussing ways to prepare a buffer. Recall that a buffer is made up of a weak acid and a conjugate base, or the opposite, a weak base and its conjugate acid. So in order to have a buffer, we're going to have a weak acid and conjugate base, or vice versa. So in the first example, you could see that in your beaker, you're going to have a bunch of acetic acid and a bunch of sodium acetate, which we care about the acetate. This is going to break up. There's going to be a minus. There's going to be a plus. And so you're going to have a buffer. So right away you know you're going to have a buffer that you could use the buffer shortcut. So in your beaker, I'm just going to abbreviate. You're going to have HA, and you're going to have A minus, and that's going to be a buffer. So we're going to use the buffer shortcut, and it's going to be H plus equals Ka times A over B. I'll just write it like this. H plus equals Ka times A over B. You're allowed to use molarity or moles for this. So the Ka of acetic acid is 1.8 10 to the minus fifth. You're going to have 0.1 moles since it was already given in moles. You might as well just use moles. And you're going to have also 0.1 moles of this one. So the H plus is going to equal 1.8 10 to the minus fifth. And then the negative log of that is going to be 4.74. So this beaker will have a pH of 4.74, and it is a buffer. So I'll write buffer here. And now we're going to go to the next example. The next example, you're going to have only weak acid, acetic acid, and then you're going to add sodium hydroxide. So let's draw a quick picture. We have a beaker here. In the beaker we only have HA, weak acid, and then to this we add OH minus. So the first question you ask, is there a reaction? The answer is yes, stoichion moles. So you're going to do stoichion moles. So look at what you got. OH minus is going to react with HA, and then what's going to happen is you're going to form water, and you're going to form the conjugate base, which is the acetate, or A minus. So we'll fill in our numbers. ICF. The moles of the hydroxide are 0.05. The moles of the HA were 0.1 to start with, and 0, of course, of this, and this doesn't matter. So this is going to run out, minus 0.05 and plus 0.05. So you're going to get 0.05 here, you're going to get a 0.05 here, and you ran out of this. Okay, now you're going to look at what you got, and you're back to solution scenarios. Do you have a strong or a weak or a buffer? Here now you have a weak acid and its conjugate base. So your new beaker that you have is going to look like this. You're going to have HA and A minus. All right, so let me just contrast this with the first example. The first example, I gave you the weak acid and the conjugate base, and that's all you had. So you asked yourself, does it react? The answer is no. So what do I have? I have a buffer, and I use the buffer shortcut, and I'm done. Here, we had a weak acid by itself. If I had asked you, I could have said, what is the pH of this weak acid by itself first? And then you would have done ice and Ka. But I didn't really ask that. All I said was, what's going to happen when you add the OH minus into here? So then you asked, was there a reaction? Yes, stoichion moles. So we did stoichion moles. And once they react, this is what you're going to have. You're not going to have any hydroxide because it ran out. This ran out. And you did some of this acid to change into some of this base. So now you have a buffer. So now you're going to use the buffer shortcut. All right, so we're going to write buffer here. And the buffer shortcut means you're going to take H plus concentration, which is going to equal, should have written concentration over there, equals Ka times A, the weak acid, over B, the weak base. And we'll just fill in our numbers. That's going to equal 1.8 times 10 to the minus fifth. And the weak acid is the 0.05. the weak base is also the 0.05. And so we get the H plus to equal that number. And of course, we already know that the negative log of that is also 4.74. So here's something interesting. We made a buffer with the exact same pH from just combining acetic acid and sodium acetate, or combining acetic acid and sodium hydroxide, and we got the same thing. Okay, now we're going to go on to number 3. We're going to add a weak conjugate base to a lesser amount of strong acid. So we have an initial beaker here, and the initial beaker has just sodium acetate. That's the A minus. So I'm going to write A minus in here, the weak conjugate base. And to this I'm going to add some HCl, H plus. Now, I didn't ask this in the problem, but I could have said, what's the original pH of this beaker? So you see there's a weak acid, you would do ice and Kb. But we're not really required for that. We're just going to add these two together. So the question you ask is the reaction. Since you're adding something to something, the answer is yes, stoic in moles. Stoic in moles. So let's write the reaction. We're adding H plus to A minus, and we're forming HA. So then you just write ICF. We copy down the moles of the acid was 0.05 moles, and the acetate was 0.10. And of course we had no acid to start with, so this is going to react fully, take some of that, make some of that. So now we have 0.05 of each of these. We have 0 of this. And then when we look at our beaker, look at what you have left in your little ICF chart. You have a bunch of HA, and you have a bunch of A minus. So you just made a buffer. And when you make a buffer, you can use the buffer shortcut. So H plus equals Ka times A over B. And you're just going to fill in your numbers, and you're going to see that this is actually going to look very familiar. 0.05 of this, which was that one, divided by 0.05 of that. So the H plus is again 1.8 10 to the minus fifth, and the pH is again 4.74. So we made a buffer completely different procedure now. Here we started with a weak conjugate base and added a strong acid, and we made the exact same buffer that we did in the problem before. All right, now let's try the next example. If we're going to be using, instead of an acidic buffer, we're going to use a basic buffer, ammonia and ammonium. So same deal. We're going to draw a picture of our beaker. Inside this beaker, we're going to have both NH3 and NH4 plus. I would not recommend using the HA and A minus abbreviations for these, because that works mostly for acids and their conjugate bases, not really as well for the ammonia, so I wouldn't do it that way. Okay, so these two are not going to react with one another. There's no reaction, it's just a buffer already. We're not adding anything into here, so you're just going to use the buffer shortcut. You have a choice, whichever one you want to use. All right, I'll go ahead and use the OH one just for contrast. So OH equals Kb times B over A. So that's going to equal Kb is 1.8 10 to the minus fifth for ammonia. And then the acid and base were both 0.1. So this is going to be 0.1 for this over 0.1 for that. They're both moles. So now you're going to get the same answer as you got before in terms of OH minus and H plus. We had the same answer before. But now you take the negative log, and that's the POH is 4.74. So 14 minus 4.74 is going to be 9.26. And that is the final pH of this buffer, which makes sense because this buffer is a base buffer. Okay, now we're going to take a beaker that only has NH3 in it, which again is a weak base. Any NH neutral is a weak. NH3 is going to be in your beaker right here, and we're going to add the HCl to it. So let's write that in here, NH3. We're going to add HCl. Again, if I asked you find the initial pH of this beaker, all you'd have to do is recognize that this is a weak base, and you would do ice and Kb. But we really don't care about that. We're just adding this in and figuring everything out. So you ask yourself, is there a reaction? And you would write yes, stoichiomoles. So go ahead and write the stoichiomoles reaction. You're going to see H plus reacts with the NH3, and the only thing that you could possibly do is put them together to make NH4 plus. You're going to do your ICF chart. You're going to look at the moles given in the problem. The H plus was 0.05 moles, NH3 was 0.10. There was nothing of the ammonium in there to start. The H plus is going to run out. When you're all done, you have a bunch of ammonium, a bunch of ammonia, and no hydrogen ions. So you look at what you got and you realize that you have a buffer. And so you can use the buffer shortcut. The buffer shortcut is going to look very familiar again, just based on the numbers I picked. So that's going to be Kb times B over A. And then you're going to just put in your numbers. So 1.8 10 to the minus fifth. And this is going to be a 0.05 for the base over 0.05 for the acid, which they're going to just divide out, and that's going to be the H plus, and then the POH is the negative log of that, which equals 4.74. So 14 minus that is going to be 9.26. That's the final pH. Again, it makes sense this is a basic pH because it's a basic buffer. How do we know it's a basic buffer? To start with, because if you look at the Kb of ammonia, it's going to definitely be a higher number, negative fifth, than the Ka of ammonium, which would be negative 10th. So therefore, this must be a basic buffer. Lastly, if you have a beaker and you have both NH4, I'm sorry, you just have NH4 plus in here, so that's the acid, and then you're going to add the OH minus into it. You're going to find out what happens by first asking yourself, is there a reaction? The answer is yes, stoichiomoles. So we're going to write our stoichiomoles, which is going to be hydroxide plus ammonium. The hydroxide wants to take the H, so you're going to make ammonia and water. We're not going to worry about the water. So I, C, and F. This is a 0.05 moles. This is a 0.10. This was a 0. We ran out of the OH. We used up only 0.05 of this, and we made 0.05 of that. And hopefully you're getting the idea of what's going on here. That you now made a buffer again, because you have a bunch of the weak base and its conjugate acid. So just finish writing this out for you, and you'll see how to get the final number in the same way we did before. 1.8 10 to the minus fifth times the base 0.05, which was this, over the acid, which was this. That gives you the OH minus. The POH is again going to be 4.74. And 14 minus that will give you 9.26 as a final pH. So to sum it all up, you can make a buffer with lots of different procedures. The first way to make a buffer in the first example was to simply add the weak acid and its conjugate base together. Okay? The second way to do it is to take the weak acid and add a smaller amount of a strong base to make the weak acid partially turn into its conjugate. Or you could do the opposite. Take a weak base, add a strong acid to it, and then make some of this turn into some of that, and you have a buffer. Or if you have a weak base and a weak acid together, that forms a buffer. If you take some of the weak base and add a strong acid, a lesser amount, you're going to turn this into this and make a buffer. And the last one, you're going to take a weak acid, add a strong base in a lesser amount, and turn it into a buffer as well. And if you want to see what that picture would look like for this, it's going to be some NH4 plus and some NH3. Same thing with this one. Some NH4 plus and some NH3 in your final beaker. So you made a buffer.